Hello, dear students. This is the section 4 from chapter 5 about water. We know that water exists in all three states, solid, liquid, and gas. Uh, the structure of water is very, very important because the structure is responsible for some unique properties or characteristics of water. For example, the structure of water composed of one oxygen and two hydrogen. They bonded together, and the typical bond between oxygen and hydrogen is called polar covalent bond. We know that the covalent bond is a typical or a type of bond in chemistry that formed by sharing electrons between two atoms. The bond angle between two hydrogen is 105 degree, the bond angle. Let's know why water molecule is polar. There are two main reasons behind this polarity of water molecule. The first one is the bent shape. We know that when two hydrogen bonded to oxygen, there is no linear line like that. It's a bent. يعني قوسة بندق يعني. Bent shape or angular shape between molecules. And there is a large difference in electronegativity between oxygen and hydrogen, because the electronegativity of oxygen is more than the electronegativity of hydrogen, so that water molecule is polar. And we know that the electronegativity means attracting or pulling electron to itself. Clear? And we studied that between water molecule, there is a typical attractive force, which is called hydrogen bond. This hydrogen bond is very important. The presence of this hydrogen bond is very important in water. That again responsible for some unique characters. For example, this question: how is the structure of water responsible for some water's unique characteristics? When we say unique characteristics, I mean the characteristics that belonging to water only, and because of the presence, mainly because of the presence of hydrogen bond, result in three main properties. They are because and water has high enthalpy of fusion. We said that fusion is melting. Enthalpy, I mean heating, and it has high boiling point and high enthalpy of vaporization. For example, when we say why water has high enthalpy of fusion, high boiling point, and high enthalpy of vaporization, mainly because of the presence of the hydrogen bonds between the water molecules. And we know that the hydrogen bond is the strongest attractive force among the all attractive force, like London dispersion, dipole-dipole interaction. And this hydrogen bond in water molecule, there's a group of bonding, and this group of molecule that they connect together by hydrogen bond, we have four molecules or eight molecules. They bonded together via hydrogen bond. This four molecule or eight molecule, they are called a group for water molecules, either in liquid state or in solid state. For example, the question says, describe the arrangement of molecules in liquid water and in ice. The answer is there are intermolecular hydrogen bonds in both. And in both liquid state and solid state, there are intermolecular hydrogen bonds. When we say intermolecular, and between two molecules of water, either in liquid state or what, in solid state. Okay, the liquid usually has 4 to 8 molecules per group. Yani when we have water in liquid state, there are there are 4 to 8 molecules. For example, one H2O, two H2O, three H2O, four H2O. These four H2O forms a group of water molecules, and they bond together by hydrogen. In solid state, all molecules are arranged in hexagonal, and this is the shape of hexagonal of water. Here we have another important question: why does ice float? Dear students, we know that there is a hydrogen bond between the molecules, but there is a small difference between hydrogen bond in water and hydrogen bond in ice. When we have water and the presence of hydrogen, because it's in liquid state, there is a flexibility of the hydrogen bond, and there is no rigidity, so that there is no more space between molecules. Here, there is no space between them. While when water forms ice, again there is hydrogen bond, but in ice, in solid, this is rigid hydrogen bonding, so that there will be more space between molecules. Because there is more space between the molecules, the density of the ice become less than the density of water. So that's why ice floats on water. Huh? Why does ice float, and why is this phenomenon important? Ice floats because it's less dense. Yes. Why? We said that there is more space between the molecules when water forms solid. Due to low density, ice forms only on the surface of it. Why? Again, because of the lessness of solid. The solid top layer insulates the liquid water beneath it, preventing a total freeze, and will kill most living things in the lake. Yet, physical properties, dear students, you may be given in the exam, list the main physical properties of water. It is transparent, yes, and if there is no color. Odorless, they want to tasteless, colorless. Yeah. Freezing point is 0. Boiling point 100 degrees Celsius. Molar enthalpy of fusion, it must be memorized, equal to 6.009 kilojoule per mole. Molar enthalpy of vaporization equal to 40.79. Again, these two values, molar enthalpy of fusion and molar enthalpy of vaporization, must be memorized: 6.009 and 40.79 kilojoule per mole. The maximum density is about 4 degree at 4 degrees Celsius. And we have two rules for solving mathematical problem. Before solving mathematical problem, we have some change of state and energy involvement. For example, when water melts, fusion and melting, heat energy absorbed, يعني endothermic process. Evaporation, evaporation is from liquid state to gaseous state. Again, it's absorbing heat, in endothermic. Sublimation, from solid to gas without passing through the liquid state, it is again endothermic. Heat energy absorbed and endothermic. Released, exothermic. Freezing, it's released, exothermic. Deposition, it's energy released, which is uh, exothermic. This is the end for this lesson. In next lesson, we will study the mathematical problem related with these two rules. Thank you.